Hello, and welcome to the next exciting installment of Digital Design. The topic of this video is number systems, and in particular, addition. So to think about addition, let's again start with addition in our familiar decimal number system. Imagine we wanted to add 3,734 plus 5,168. Just like we learned in elementary school, we would do 4 plus 8 makes 12. You can't write 12 as a single digit, so instead we write a 2, and we carry a 1 to the next column that has 10 times the weight. Now we can do 1 plus 3 plus 6 makes 10. Again, you can't write 10 as a single digit, so we add a 0 and a 1 in the next column. 1 plus 7 plus 1 makes 9. 3 plus 5 makes 8, and we're done. Binary is similar. Let's say we wanted to do 1 plus 1. That would make 2, which in binary is 1, 0. That's not a single digit. So we write the 0, and we carry the 1 to the next column. Next we do 1 plus 1 plus 1 would make 3, which in binary is 1, 1. That's not a single digit, so again we write the bottom 1, and we carry the upper 1 to the next column. 1 plus 0 makes 1, and 1 plus 0 makes 1. We could check this. 1, 0, 1, 1 is 8 plus 2 plus 1 is 11 in base 10. 0 plus 1 plus 1 is 3 in base 10. And the sum 8 plus 4 plus 2 is 14 in base 10. Sure enough. Let's do some more examples. Say 9 plus 5. 1 plus 1 is 0, carry a 1. 1 plus 0 is 1. 0 plus 1 is 1. And 1 plus 1 is 1. So again, this makes 14. On the other hand, if we were doing 13 plus 6, sorry, that's not 13. This is 11 plus 6. 1 plus 0 makes 1. 1 plus 1 makes 0, carry a 1. 1 plus 0 plus 1 makes 0, carry a 1. 1 plus 1 plus 0 makes 0, carry a 1. And we get 1, 0, 0, 0, 1, which is 19. That's correct, but our answer is no longer 4 bits. This is called overflow, where we have another digit beyond what we started with. So digital systems often operate on a fixed number of bits, and overflow would occur when the result is too big to fit in the number of available bits, like when we added those two 4-bit numbers and we get a 5-bit result. Often the extra bit is discarded, which would lead to a potentially incorrect result. An infamous example of overflow is on the Ariane 5 rocket in 1996. This was a next generation rocket. The version 4 worked just fine, and the 5 had a larger engine. When it took off, it veered out of control, and after 40 seconds, veered off of control, broke up, and exploded, carrying $500 million of rocket and cargo. So the problem was traced back to the larger engine and the control system for that. The horizontal velocity of the rocket was stored in a 16-bit integer. And with a more powerful engine, the velocity got faster, and the number overflowed gave an incorrect result, sending the rocket out of control. So as you can see, overflow can be a big deal, and when you're working with binary numbers, you need to think about the range and avoid overflow.